number 6 from the 2014 examination paper for Dynamical Systems and Chaos. Question 6a asks you to determine fixed points of periods 1 and 2 for this two-dimensional discrete map and classify the fixed points of period 1. And 6b asks us to find the intervals, the sets of points which never escape on the interval 0, 1 for this mapping. And we get a Cantor set and we need to find a fractal dimension of that Cantor set. So for 6a, we have this two-dimensional discrete map. To find fixed points of period 1, we need to solve xn plus 1 equals xn equals x, say, and yn plus 1 equals yn equals y, say. From the second equation, you can see that y is the same as x. We can substitute that into the first equation, and we get this simple quadratic formula. We can solve this either with MATLAB or by factorizing, and these are the fixed points. And notice that x is y, so the first fixed point is minus 4, minus 4. The second fixed point is 4/3, 4/3. To determine the stability of these fixed points, we use the Jacobian matrix, which is given here. We substitute the values for x and y. For the first point, the eigenvalues are 1.5 and minus 1. Because the modulus of 1.5 is bigger than 1, this gives us an unstable branch, so this fixed point is unstable. For the second fixed point, we get these eigenvalues. If you take the modulus of both of these eigenvalues, then the modulus of both of these is less than 1, so therefore this fixed point is stable. To find fixed points of period 2, we want to solve xn plus 2 equals xn equals x, and yn plus 2 equals yn equals y. And we get these expressions here. Now, if we put these expressions into MATLAB with the solve command, so we have xy equals solve, etc., then the fixed points of period 1 again pop out. So you will know if the equations are correct or not because these two fixed points pop out. In this particular case, these are the only points that pop out. There are no other fixed points, so there are in fact no fixed points of period 2 for this mapping. There are two fixed points of period 1, but there are no fixed points of period 2. For part B, we have this tent map. So this branch is given by y equals 5/2x, and this branch is given by 5/2 minus 5/2x. So you can see that when x is a half, then fx is 5/4. So we want to determine which points remain bounded after one iterate, which are given by these red bars here. So you can see if a point starts on this red bar, we go up to the curve across the diagonal, that remains in 0, 1. In here, we go up to the curve across the diagonal, that also remains in 0, 1. Points outside of the red bars, so for example in here, if we start at this point here, for example, we go up to the curve, across the diagonal, and then this point is outside 0, 1. Okay, so that point is outside 0, 1. So all points in here are unbounded after one iterate. So the points that remained bounded are in here, and in here. And to find this point, we just want to know when does 5/2x equal 1. So when does 5/2x equal 1? It's when x is 2/5. And for this point here, this point we want to know when does 5/2 minus 5/2x, which is this branch, when does 5/2 minus 5/2x equal 1? And if you work that out with simple algebra, this is 3/5. So S1 is 0 to 2/5 and or 3/5 to 1. Now to find the S2, we show these points here, S1, on this axis because we want to know which points map into these. So for example, if we draw the 0 to 2/5 and then go backwards, then 2/5, we want to know when does 5/2x equal 2/5. And again, simple algebra shows us that x has to be equal to 4/25. So these black points map into these red points. So our first interval is 0 to 4/25. Then you can see that these red points also map into these black points here by reading across. And again, you can find this point quite easily. And you'll see that there are 4 regions given by 0 to 4/25. And then these red regions reading across give you 6/25 to 2/5 or 3/5 to 19/25. And this is the final fourth region. To determine the fractal dimension, at each stage, one segment is replaced with two segments, so we have log 2, and the scaling is given here. So the scaling is 2/5, because at each stage, these segments here reduce by 2/5. So the epsilon is 2/5. So using the formula for the fractal dimension, we get it's about 0.7565. And that concludes the solutions to question number 6.